Hello and welcome to another episode of That Fabric Guy here on YouTube. My name is Basland and today I will be diving deep into the Fabric Capacity Metrics app. With the Fabric Capacity Metrics app in Power BI, you can find out what items in your Fabric capacity are using a lot of compute resources, and you will use this in order to find out what your spending baseline is. I've created another video on how Fabric is licensed and what the cost structure is there. And today we're going to look at the report that Microsoft gives you in order to find out where your spend is located. So if you find yourself getting throttled, or if you're experiencing overages and outages, then this app is definitely something for you. Now, one thing to keep in mind before we dive into my laptop and do the demo is that you want this app to run in a workspace that is hosted on a Power BI Pro license. You do not want to have your Fabric metrics reporting running on your Fabric capacity, because if your Fabric capacity goes offline because you're using too much, then the report goes offline as well and you cannot see why you're offline. So please host your Fabric metrics app in a different workspace and host it on a Pro license workspace. All right, let's dive into my laptop and figure out what we can do. So we're looking at the Fabric Capacity Metrics app here in Power BI. This is a Power BI report that has been created by Microsoft. And if you think, okay, Microsoft created Power BI reports, then you think these should be awesome reports that are super fast to work with. And then you start actually working with this report and it will be very slow. Yes, I am a bit bummed that it is very slow, and you could be as well. But on the other hand, if we think about what is actually underneath this report, what actually is the data set that we are working with, it is literally trillions of rows in a Custo database. So there is all the usages of all Fabric capacities of all Microsoft customers in the entire world are living inside of this data set. So it is a massive data set that we're working with. We're only seeing our own Fabric capacities, of course, the Fabric capacities that we as a user have access to and are capacity administrators of. That is important to know. And from here we can figure out which capacities these are. So in my current tenant I have two paid capacities and I have a trial capacity. I've selected one of the paid capacities that we're looking at today, and we can look at just that one capacity. Now, mind you, in this report we can figure out compute usage and storage usage to see why are we getting cloud spend and where is it going. But we're only going to show that for the past 14 days. So you can only look back 2 weeks at a time. And in a later video somewhere in the near future, I will probably be creating a solution to persist that information into a lakehouse and to store all of this into your own Fabric environment in order to analyze data further back in time. For today, what are we looking at? We have selected the Capacity Metrics app, we have selected our capacity name, and we see a few different visuals here on the screen. So the first one is the multi-metric ribbon chart. It's just the name of the chart itself, and what it's actually showing, it is showing the CU usage over time. And we're looking here at the CU usage at a certain date and against certain types of usage. So if we click on this visual, we will find that we see item kind here and then the dates on the bottom, of course. So here we can find out quickly how much spend are we generating over the past couple of days per day and per item kind. So we can see, for example, here that we are spending on Synapse Notebook, we're spending on Lakehouse, we're spending on Data Activator, we're spending on Pipeline. And then suddenly on Tuesday, the 2nd of December, 2 days ago, we were spending quite a lot on Warehouse. I don't know why there was a big spend on Warehouse, but at least we can see that there is a spend that is going up. And probably a large part of that is coming from a Warehouse item. Okay, that's one. Then we have few different tabs here. Then we are on the duration tab. And what we can see here is when we hover over things with our mouse, there's item kinds that have been running for a certain number of seconds. So this is the actual time taken to complete the operation, including Fabric workloads. And we see here that 87,000 seconds have been spent on the activator, 7,000 seconds on Synapse Notebooks, 1,700 seconds on pipelines, and so on. This is not as important as your compute usage, because compute usage is a number of compute units over time. So that is more important than just the time, but at least we can look at time in here. Then we can figure out on the operations tab the next thing. And here we can see things like what is actually running, how many individual operations are taking place on these different Fabric workloads. So we can see that there's 16,000 hits on the Lakehouse on Friday 28th November. There were today 1162 hits on the warehouse. There were function sets that were being executed. There's Lakehouse operations and so on. Again, this tells us a little bit about the usage of our capacity, but it does not necessarily tell us how expensive things are. So again, I'm still looking for the CU tab as my most important thing here. And then the users tab. This is the distinct number of users who performed operations. So here we can see that 2 users have performed operations against the warehouse, and then another 2 for function set, another 2 for data sets, 1 for Synapse notebooks, 1 for Lakehouse, and so on. This is a small capacity in a small tenant, so nothing much happens. But in a larger organization, it might make sense actually, if you have lots of usage, to look at how many users are actually working with certain workloads, because maybe maybe a workload is generating a lot of spend, but then again, if a lot of users are happy with that and using it, then maybe it's okay if that spend is happening. So this is something that is kind of interesting to look at. Now I'll go back to the CU tab in here, and now it's a little bit quicker because it's cached data now. What we can see here is the total spend that we have over time. And then on the right side, if we move over to the utilization tab, and here we see a bar chart that shows a percentage against a target, and the target is set to 100%, of course. And this target is the CU percentage limit, the CU limit. This is the amount of compute that we get with our capacity. So mind you, if we hover over one of these bars, we can see that in here actually we have a 60 compute unit seconds, or CUS. It's the last line that we see here. That is the 100% line. Why is it 60? We have an F2 capacity in this case, so it's the smallest capacity that we have, and an F2 capacity gives us 2 compute units. These 2 compute units give us 2 compute unit seconds per second, right? It's 2 multiplied by 1. And now every bar in this graph is a 30-second time window. So this time window contains a total allowance of 60 CUS. So that's the 100% line. Now, if you have, for example, an F64, then this will be 30 times 64, and that will be your 100% line. Okay. So we can see here how much our allowance is and how much we are using inside the allowance over time. And this is very interesting to see what our baseline capacity is doing and what our usage patterns look like. So we see that in here we're using a total of 7.36 CUS in this 30-second time slice, and we know that we have an allowance of 60%. So we're using about 12.2 or 12.3% of our allowance. So even though we have the smallest capacity available, we're still using only maybe 1/7 or 1/8 of the total capacity. That is maybe good news because we're not looking into overspending anytime. On the other hand, we are probably overspending on the F2. We should be. I mean, why can't I buy an F1, right? So this is something that is of interest. Now, what we can do here, something I do a lot, is I will use the Power BI cross-filtering behavior. So I will click on a date, for example, on Tuesday the 2nd, where this massive warehouse usage peak was. Now I can see over time what my spend looks like. When I start clicking here, the time slices that we're selecting are super small. Now the thing that we can do here is we can look at our throttling and overages. In this dataset we do not have any throttling or overages issues. However, if we do have usage that goes above the 100% line, that will trigger throttling and overages in our capacity. And we have interactive delays, interactive rejections, and background rejections. And this is where we can find out how much Fabric is trying to slow us down and to make us spend less compute in order for us to not go into a rejection or overage situation. Again, as I said, there is not much data in here to actively work with. Then again, if I go to the overages over time, probably there's no data in here. This is something that we can simply not work with. It's a 0% line. What we would see here if we were to have overages on our compute is that there's a carry forward percentage. Okay, so what happens if you spend more than you are allowed to? What you will do is you will basically borrow that from future you. Your future compute allowance will be used for the compute that you generate today. This carry forward percentage can be a lot. You can overspend by a lot, right? You can easily borrow a lot of compute from tomorrow and so on. And what the overages chart here is going to show you is it is going to show you how much percentage are you above your current allowance. So are you 10 times over or 100 times over? And it will show you the burn down rate in blue. In this case, it's empty, of course. This burn down will show you how fast you are burning down your spend. Now, if you're not generating any additional work and any additional compute power, then your burn down will be at the speed that your fabric capacity is set at. So at an F2, you would get 2 compute units. Over time, that is 60 compute unit seconds per 30 seconds time window will be your burn down. So if your overage is, I don't know, 6,000 CUS, then you would need 100 30 second time window. So 50 minutes you will be out of your... That is all important for the high level stuff. Now what we see at the bottom here is the spend by item for the past 14 days. And now because we can cross filter here, we can actually select data that is in a single day. That is, I think, more useful to look at, because usage per item over 14 days, and I need to do the mental math to divide things by 14 and so on to find out the average spend per item per day. I like to look at just a single day. Now I am interested in what happened on the 2nd of December here on this Tuesday. So that's why I clicked on that one. And now we get the table in here that is sorted by CUS usage, and again per item. And that will show us what parts of the platform are actually generating a lot of compute or actually consuming a lot of compute. Okay, the items in here have a hierarchy. They are shown to be in a workspace. So internal data warehouse here is a workspace. Then KDF 2.0 Fabric is a workspace and so on. And we have warehouse, Synapse Notebook, Lakehouse, Activator. These are the item kinds. These are the same item kinds that we find in the ribbon chart up top. Then the last piece of this hierarchy at the last backslash is the name of the object. So we have a warehouse that's called internal data DWH. We have a notebook that is called one.logging orchestrator and so on. And these are generating compute unit usage. And we can see that on Tuesday the 2nd, we have used up 38,887 CUS, and that is only a little bit out of our allowance. So our allowance for an F2 capacity in this case is the number of seconds in a day, that is 86,400, and the number of compute unit seconds that we get for an F2 is 2 times 86,400. That is the total number of CUSs that we are allowed to spend in a day, and we only spent 38,887. That means we're well within the limits. We're easily within the limits. However, if we were not, we could find out what is actually going to, what we're actually spending here. So on the warehouse queries, we're spending 15,000 CUSs on that day. On the logging orchestrator notebook, we're spending 10,000 CUS and so on. So here we can find out what's actually generating the spend on a per item level. And that is really cool, because that helps us to find out if we are looking into overages, where are we actually generating that spend? Where are we actually consuming a lot of capacity? Now, one more thing I want to show you about the compute is the following. If we right click somewhere on the utilization over time chart and we go to drill through, we go to time point detail, we will get a detailed Power BI page with just that 30-second slice. We can see that on the top left here, that we have this 6:00:30 p.m. to 6:01 p.m. That is a 30-second time window that we are working with, and we are well within our limits here. We only spent 13.5 CUSs out of the 60 CUS that we have available here, and that's 22.47% of the limit. Okay, so we're super easy here. Now, mind you, in this tiny 30-second slice, a whopping almost 10,000 background operations are running, and these 10,000 background operations are found here in the in this table. These background operations are usually carry forward operations that have been started in the past, in the hours before, and are then smoothed out over the next 24 hours, right? So that is one thing to keep in mind. If you're using Fabric compute power, you're not using it as is. So with a regular virtual machine, or if you buy hardware and run a server, then you need to allocate physical resource. You need to allocate a CPU and RAM memory and so on. And that is what you get. With Fabric, you can use more than your allowance, and that will be smoothed out over the next 24 hours. And that's how you end up with 9,920 background operations in that tiny 30-second slice. Definitely there were no 10,000 activities that were happening on this capacity. It is just background operations. We have been running multiple queries. We've been processing the ETL workflow for the internal data warehouse. A lot has been happening. And all of those very granular points have been stored in here. And that's the 10,000 operations that we're looking at. So what we're seeing here is that the total COSs that have been used is 38,000. In this time point, it's only 13. So from the 38 or 39,000, only 13 are used, and it's consuming 22.5% of our base capacity. So we're well within limits. And what we can see here is all the details that we find that we are doing apparently some Copilot in Fabric, some notebook high concurrency pipeline runs. We're doing one leg writes, one leg other operations, and a lot of things that are happening in the background. And now again, here we find a burn down table, and there's no add or burn down and minutes to burn down in here because we're not in an overage situation. Again, if we were to have an overage on that specific time point, then clicking on the time point, drilling down, this table will show us which experience in Fabric, so that's analysis services or Power BI semantic models, data integration, I think, Lakehouse, machine learning, and so on, will be adding to the overage or burning down from the overage. So that is something that we can see in here as well. Now the interactive operations for this time range are empty because I think at this time nothing was actually happening. So if we go back here, we find a few of these red slices. If we go here and drill through, then we should be able to find for that time point some interactive operations, because the red in that table gives us the interactive operations. Interactive operations can be things like Power BI Direct Lake. And as you can see here, one of our colleagues, Kevin, has been querying a lot of data sets in the data warehouse. And this has been consuming a tiny bit of compute. It was only 13 CUS. And within this time point it was 1.3 CUS. So this was a tiny usage, but probably this was Power BI Direct Lake operations from a Power BI report. Again, at the same time, 14,000 background operations were running, and those background operations again were the carry forward, the 24-hour smoothing from things that have happened in the past. All right, so that's it about compute. Let's dive into storage for a little bit, because as we know, Fabric will bill you for both compute usage as well as for storage. Now, storage is super cheap, and usually storage is, for me, an afterthought. We spend hundreds of euros or dollars or thousands per month on compute, and maybe we spend a few bucks or maybe 10 or 20 bucks on storage. But if you have a situation where you store a lot of data on one leg, then this is a tab that you might want to be looking at. So the storage in here will tell you the number of workspaces that this capacity is running in, the storage that is happening inside those workspaces, and the billable storage, because you can have billable and non-billable storage. It will show you the billable storage. The table up top here will give us the top 10 workspaces by billable storage. As you can see here, that the KDF 2.0 Fabric workspace is actually consuming 47 gigabytes of billable storage, and that sounds like a lot. It is really not. I think a gigabyte of billable storage runs about 2 or 2.5 cents, so this is not really really expensive. Now we do see that storage by date, it is going up just a little bit. I'm not really worried about this, but at least we can now find out where our storage bill is going. So we see that we're getting billed for 116 gigabytes. That is probably running us a couple euros. If you have a large bill and you're invoiced by Microsoft or by your partner, then check your storage. I mean, if it's getting out of hand, then probably you want to dive in here and see what objects are you getting billed for. All right, as I said, this is a very handy app. It's maybe not the nicest Power BI report in terms of look and feel. It is also not the quickest, but considering that there's trillions of transactions in just a two-week rolling period, or at least I imagine it to be trillions of transactions, this is actually quite cool, and it will help you diving into the usage that you have on your compute and storage spend inside Microsoft Fabric. In a future episode, as I mentioned, I will dive into how we can actually persist this information, write this data to our own Fabric Lakehouse, and then do reporting on top of that, because then we have control over the number of days of history that we keep, and we can also create our own reports that maybe are a little bit quicker. Now, if you like this video, do not forget to like the video on screen, so hit that thumbs up, and subscribe to my channel. The only way that I can get more subscribers is by you clicking subscribe, And subscribing to my channel comes with a big benefit to you, because then every week when I publish new videos like this one, you'll be the first one to know. And I will be very happy because by subscribing to my channel, you will tell YouTube that you like content like this, and YouTube will then publish my videos to more and more users. So hit subscribe, and I'll see you next week.